All right, so sometimes when I find something difficult to understand, I like to just implement it. And so one thing that's pretty interesting, at least, is reduce. So let's implement reduce. That's Array.reduce. So I'm just going to pop open Visual Studio Code. And maybe I'll make like a new, go into learning, make a new file, pop this open in VS Code, close the other one, and we have this thing. Is there a way I can just like run this thing? I want kind of like a nodemon. Is that a thing? Can I just do that? Oh, cool. Okay. Yup. Nice. All right, that's what I wanted. So implement reduce. So there are a few things about reduce I know, and I could do a test-driven situation, but I think I want to add it to the array prototype because that would make it easier to like test and run and stuff. So let's say array prototype reduce 2 equals my new function. And you have to use function here. You can't use arrow function because you want the context to be bound to the. You want to use this here, and this is not going to be. It's going to be the module. If you use arrow function, it's going to be the instance for prototype functions when you use this regular function syntax. Function, what do you call it? Declaration, statement, function statement, expression, function expression. Yeah, I think that's what it's called. Okay, so this here is going to be an array. The this keyword is going to be an array. And so if I return this dot reduce, I think that would work. So let's try it. Let's make some kind of a reducing situation. Let's do the classic add two numbers, shall we? Add equals a b, a plus b. This thing, reduce, add. Nope, that's not how it works. Would that work? Yeah, that would work. Probably should have just inline that, but what do we got? 15? That seems right. Cool. So we know that situation is working. Let's make up something else. So say we want to like multiply everything or something. Let's change this array to an object. Maybe that would be fun. So I know this takes a function that takes the accumulator and next, and then you can provide a default. And so we want an object. Do I have my parens up? Yep. Okay, cool. So we're going to return an object where the key is the next, and the value is next. And I don't know, times 5, whatever. We're just making up silly examples here. Oh, this is a one-liner. This is a one-liner. Look at this. One-liner. Yes. Yes. Now, is this more confusing or less confusing? Because we're adding some parens and making it on one line. Okay, all right, that looks okay. I think I understand what's going on here. We're doing an accumulator. We're turning it into an object, blah, blah, blah. Okay, did it work? Next, 25. Oh, no, what I meant was next, dynamic key. It's going to be, hey, there we go. 5, 10, 15, 20, 25. Cool. That makes sense, but we haven't actually implemented anything with reduce. Okay, so what do we need to do? We need to say this is going to take some function and like the default, right? And then so we can't use reduce. Obviously, we want to use something else, and you can't use map because reduce can result in, as we see here, like a completely different type, and it's not going to be even the. It doesn't even need to be the same size. Obviously, this is completely different type. So I think we should just loop. Let's just try and loop. I don't think there's an array function that we could use here. So what we want to do is loop over the this items. Let's go with the classic for loop, see what that looks like. For I is less than this dot length, I plus plus, oops, and then in here we get all the items, like that's an item, and what we want to do in the most basic case, what we want to do is call the function. Oh, we need an accumulator. Default or, oh, this is going to be tricky. Yeah, let's just go with default for now. We'll come back to that. Why is it expected? Identifier expected. Really? Why? Is default a reserved word? Oh, default is, interesting. Okay. Well, we can call it something like initial. How about that? Cool. So we got the accumulator, and we're going to say accumulator equals whatever. At each round, it's going to be whatever we return from the function. The function gets the accumulator and the next item. This feels like I need to return something, and maybe this works. How do I know? How do I know if this is? Did it? Yeah, that worked. Cool. And we're done. No, we're not done. Oh, we're not even calling our function. Oh my gosh, this whole time I was just calling that one. It could have been broken the entire time. I'm gonna just trust that it was not broken before. Oh, that could have been broken the entire time. That's hilarious. All right, well, now we're actually calling our function. So now we're actually doing a valid test, and we got non here, which is expected because when we're not giving an initial value here as the second parameter to reduce, okay, so that's a whole, now it thinks it's a string. Anyway, when we're not giving an initial value here, it's setting the accumulator to undefined, and so undefined plus a number is not a number, so that's why we're getting not a number there, I believe. And this is interesting though. So it thinks we're getting a string. We're calling the function with because I'm setting initial to an array. I think initial here, if it's 0, then yeah. So if initial is an array, empty array plus 1, if we just plus 1 is 1, but I think it's a string, if I'm interpreting what's going on here correctly, which means if I do a string plus a number, that should also be a string, and you get 1, 2 instead of 3. Yeah, so that was what was going on when I was providing the wrong default. But anyway, if we don't have a default, the first one should be the first element in the array. We can see this if we go to yield. We're going to need this too. Oh, look at that, password parity. MD and reduce. I know I've looked at this page before, many a time. So, initial value. These little brackety things means optional. The little optional comma. If an initial value is provided, yes, it starts at index 0. But if an initial value is provided, it starts at index 1. No, it starts at index 0 if initial value is provided. If initial value is not provided, index starts at, oh, interesting. So we didn't even provide current index, and we didn't provide the array. We got to do that too. Here we go. Here's the stuff. There's the accumulated value of the previous string value or initial value if supplied. See below. See. Can I click this? You're not going to give me a link? Oh, initial value. Blah, blah, blah. If no value is supplied, the first element of the array will be used. All right. We got stuff to do here. We need index and, right? No, this is the stuff for this. Index. Oh, that's just I. We have that. Oh, and the array. That's just this. Okay, well, that was easy. Now we need to say, if this is not here, give it, then the accumulator should be the first item in the array. Okay. Let's write bad code. If initial. We can't say not initial, because initial could be false. It could be 0. It could be empty array. It could be stuff like that. So when you say if type of initial triple equal, because we always know that the type of is always going to be a string. Undefined, don't spell it wrong. And so if we don't have it, then that means, put this up here. That means accumulator should be the first item. Oh, goodness gracious, we're going to have to do this too. Dun, 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 dun. So, this sub-0, and then I equals 1. Equals 0. Cool. You know what? Let's do this. This would make more sense if I was a person reading this code, right? So accumulator becomes the first item. We increment the first index, which fulfills that thing, and then does it work? Does it work? Does it work? 10. I took away the 5, so that is correct. This is making this much more confusing. Cool. I think that works. Is this everything? Is this all we care about? We care about passing all these things. We could write tests for these. We should probably write tests for these because my little example doesn't cover these. This would not pass mutation testing, maybe. If that would even work for that, I don't know. But I think that's it. This is like a reasonable, I think, implementation. Now, could we optimize this? I mean, for performance, we could definitely write a slightly more performant loop, because this is one of those things that's like fundamental to JavaScript. You're going to want it as humanly fast as possible. So I could combine these declarations. I could do the plus here. That's probably not saving us a whole lot of anything. Probably the loop is the biggest thing. I could maybe do a while backwards instead to avoid the checking the length every time. No, that wouldn't work because you have to go forwards. I can make some minor things, but this overall looks pretty good to me. So anyway, that's how I would go about just like implementing something from scratch. Just like see what you can do with it, watch it break, figure out why it broke. You actually learn a lot just from not just about reduce, but about JavaScript in general, just by churning through stuff. So yeah, I guess that's this video. I will see you guys next time.